So the final unit we're talking about investment. Is the computer screen coming through on the other sites, by the way? Perfect. Okay, so our final unit, unit 3, is on investment. And we're going to start out talking about simple interest. Mainly because it is the simplest form of interest to attack. And also because many of our formulas that we're going to use in more of the complex examples involve the simple interest formula that gets used in some of those as well. So anyway, the whole basis of simple interest is the simple interest formula, which is I equals P R T. Of course, that is P times R times T, where I stands for the dollar amount of the interest. P stands for the principal. Principal is the starting amount, or the amount of money that is being acted upon in the loan or investment or whatever it is we're talking about. R stands for rate. A rate is nothing more than a percent in its decimal form. And T stands for time, and time is always in years. So let's say that we invest $4,000 at 3% simple interest. For 5 years. Find the amount of interest earned. So this is just our simple interest formula. Do we know I? Well, the amount of interest earned is what we're looking for. So I is what we're trying to find here. Do we know P? Yes, we do. It is the $4,000. That is what we're starting out with. Do we know R? Yeah, we better, because we don't know I. We can only have one unknown, right? So we got to know everything else. R is the 3%, but we're going to write it as 0.03, the decimal form of 3%. And our time? 5 years. So right, that is 5. Which ends up giving us, what, $600 is the amount of our interest. Now, quite often the amount of interest isn't necessarily the important thing we're looking for. Quite often we're looking for something called a maturity value. The maturity value is simply equal to the original principal plus whatever interest has been accrued or built up on that principal. So to go back to the previous problem, if we're asked to find the maturity value, all it's going to be is the original $4,000 plus the $600 in interest. It'll mature at $4,600. Any questions so far? Well, from experience, most of us know that simple interest does not generally get used on a 5-year loan or investment. Usually, simple interest is only used on short-term loans. For example, we might have, used to happen to me quite a bit when I was running my construction company more heavily. You get close to payday and you haven't finished a job and you haven't been paid yet, you're not going to ask your employees to go a while without getting paid. You're going to find some way to pay them. So you go to the bank and you take out a short-term loan to cover your payroll until you finish a job. So you might go to a bank and ask to borrow $3,200 for 3 months. And the bank gives you 7% simple interest. How much has to be repaid? Basically, what are we asking for here? Are we asking for the amount of interest? Or are we asking for the maturity value? We're asking for the maturity value. Now, to find the maturity value, of course, we first must find the amount of interest. So we're going to start out with the simple interest formula. So we're looking for the interest. What is the principal here? $3,200. Rate, 7%, so we're going to write it as 0.07 as a decimal. Now here's where it gets a little tricky on this one. We said our time is always in years. What's that? 3 months is going to become 3/12. 12 months in a year. You could write it as 1/4 if you wanted to reduce it, but I'm going to leave it as 3/12 just because you can see that it's 3 months out of 12 months in a year. So it's kind of signifying what it's all about there. So now we multiply that out, 3,200. Now on your calculator, the easy way to do this is going to be like 3,200 times 0.07. And then instead of using the fraction key for 3/12, so you just do times 3 divided by 12. And we get $56. So the amount of interest built up, or the term that's used as accrued, is $56. Yes?
Could you also write the 3/12 as a 25?
If that's easier for you, yes. But if we had like 5 months, of course, it's not going to be quite such a simple decimal. But yeah. So now that's our interest. Our maturity value will be the original 3,200 plus the $56. So $3,256. What do you think? Good stuff? Well, let's say the interest, and we're going to assume this is simple interest, on your loan for 1 month is $84. The rate is 6%. It depends on what you're borrowing for. Right now, if you're borrowing for a home, you'd be getting between 3.5% and 4.5%. If you have really poor credit, it might be as high as 5.25%. For cars, again, it really depends on your credit rating. You can get as low as like a 1.9 all the way up to like a 9 or 10%. If you're buying recreational vehicles, campers, four-wheelers, boats, you're going to be paying, if you have great credit, 5% or so up into the 12-13% range. So find the principal of the loan. In other words, how much do you actually owe at this point? So we're looking at I equals P RT. In this case, we know I is $84. Do we know the principal? No, the principal is what we're looking for. Do we know the rate? 6%, 0.06. Do we know the time? 1 month, so 1 over 12. There's one we're making into a decimal. Wouldn't work so well because that'd be 0.0833333. So have some round off errors when you punched it in. Now, since there are 12 months in a year, this is a good time to bring it up. There is a good chance of round off errors here. So when we do these, it's what I call keeping it in your calculator. You don't want to write down numbers and type them back into your calculator. I'm going to show you how to get around that here. So mathematically speaking, the first thing we should do is combine these numbers. The 84 isn't going to change. 0.06 times 1 over 12 is going to be 0.005, correct? Okay. Now that one doesn't have a decimal in it. But I'm going to show you here how I do this. 0.06 times 1 divided by 12 is going to come up in my calculator as 0.005. Now I'm going to use that to solve this equation. My next step is going to be to divide by that 0.005. Rather than typing that back into my calculator right now, here's what I'm going to do. I'm going to type in the 84, and then to divide by the 0.005, I'm going to hit divided by, and most of your calculators have an ANS keys, the answer key, down by the equal sign. You have to hit the shift or the second button, and then the ANS key. That's telling your calculator to use the previous answer. So it's taking 84 divided by the previous answer, which is that 0.005, which will give us 16,800. On your key, it should be down by the equal sign. It's actually on the negative, I believe.
I have 0.42.
0.42, you must have multiplied instead of, yeah, you multiplied instead of divided. $16,800.
You hit the second button before you hit it?
So you type in the 84 first, and then divided by, and then second, and then ANS. So now that you've punched it in and it didn't come up right, it won't work now.
Oh, yeah.
So you'd have to go back and you have to punch in the 16,800. Now, since it came out to 0.005, it's not that big of a deal. But if we're like some really long, ugly decimal that we would have to round off to write it down, then it's more important. Here, I'll pause. So we can use the formula backwards. Now, in your book, what the book does is it gives you all sorts of variations of the formula. It'll tell you this, that P is equal to I over R times T, which is great if you want to memorize extra formulas. But in reality, it's just this formula, and you're using a little bit of basic algebra to solve for that missing variable. So let's say that a $4,800 investment earns $96 in interest. Over 6 months. Find the rate. So again, we're just looking at that I equals PRT formula. We know the amount of interest is $96, so we'll put 96 in for I. Do we know the principal? Say yes. Yeah, $4,800. Do we know the rate? No, it says find the rate. That's what we're looking for. So we're just going to put R in there. Well, we better know the time. It's going to be 6 months. So 6 over 12. Perfect. And now again, before we do anything, we have to combine the numbers on this side. Now, once again, I use nice, neat little numbers like 4,800 and 6/12, which combine to make 2,400. So that's 2,400 times R. Next, we're going to solve by, perfect, dividing by 2,400. So 96 divided by 2,400. We get 0.04. Is that my answer? All done? Kind of, but I really should convert it to what? 4%. Good. Let's do a couple more examples of those. I don't know why there's a huge space in the middle of that, but pretend there isn't. An investment of $5,200 grows to $6,000 over 16 months. Find the rate of return. In other words, find the rate. Rate of return. Always find the rate is all it's really. Rate of return is just a fancy way of saying rate. That's me throwing in fancy words to confuse you. So, what's I going to be here? Is it going to be the 6,000? No. 6,000 is the maturity value. 800, where's the 800 come from? Perfect. 6,000 is our ending balance. We started out with 5,200. That means we had to earn $800 in interest. So I is 800. What's P? That is 5,200. R? Yeah, we're looking for R again. T, the time, will be 16 over 12. It really doesn't matter. All I'm going to do is I'm going to combine the 5,200 and the 16/12 right now. I'm going to do 5,200 times 16 divided by 12. That's actually going to give me 6933.333. So now here's a case where I need to leave this in the calculator, because if I write this down and I punch it back in, there's going to be a round off error. So notice it's still sitting in my calculator, 6933.33333. My next step is going to be to divide by that number. So this is where I'm going to take my calculator. I'm going to go 800 divided by, again, second answer. And it gives me 0.11538, blah, blah, blah. If I tell you to round to the nearest hundredth of a percent. Now, when we're dealing with percents, a lot of people mess this up because they look at this and say, hey, the nearest hundredth is 0.12. Is that correct? No, why not? Because I still have to change this to a percent. To change it to a percent, I have to move that decimal point 2 spots yet. This will be 11%, not 0.11%. So it's after I move the decimal point that I have to be to the nearest hundredth. So I'm going to write this whole thing down, or at least several decimal places. So 0.115385 is my R. Then I'm going to move my decimal point 2 spots to make it a percent, 11.5385%. Now I'm going to round it off to the nearest hundredth, which is right here. The 8 tells me I round to 11.54. Any questions?
5.4 or 5.5?
5.4. The 3 goes up to, it was a 3, so it goes up to 4. At 4.5% interest. How long does it take for $3,800 to grow to $5,000? Okay, once again, this is still a simple interest. I equals P RT. What do we know? Do we know I?
Interest, 4%.
Well, we know R is 4.5%. Do we know I? 1,200. Good. We went from 3,800 to 5,000. The difference has to be our amount of interest. So $1,200 in interest. Do I know the principal? P.
Yes.
Yeah. 3,800 is what we started with. Do I know R?
Yes.
4.5% is going to become what as a rate? 0.045. Very good. 4.5% becomes 4.5%. Then we have to move that decimal point 2 spots to make it a rate. To make it a decimal.
How'd you get 0.045?
4.5%.
Oh,
4.5% becomes 4.5%. Then you got to move it to 2 spots. And of course, T is what we are looking for here. So I have my 1,200 over here. I'm going to take 3,800 times 0.045. Giving me 171. What's next? Divide by 171. So 1,200 divided by that previous answer. 7.0175 is my time. That's 7.0175 what? Years. Time is always in years. If I wanted to change, now I could leave it like that. That'd be just fine. Or I could change it to 7 years and then take the 0.0175 times 12. So subtract the 7 full years, take the 0.0175 times 12 if I wanted to get months. And it comes out to 0.2 months. So it's basically 7 years and then less than a quarter of a month. If you really wanted to say 7 years and 1/5 of a month, that's fine. I would just say 7.017. Number of days? You could. That'd be 6 days, yeah. 7 years and 6 days. 7 years and 6.3 days if you want to be exact. Actually closer to 7:20 in the morning. I'll only ask the question that way if you guys really upset me between now and that test. Bring food? No, my car needs to be washed. That'll help. My lawn needs to be raked. Okay. Let's say that Sam borrows $3,100 at 6.4% simple interest. For 90 days. Find the interest. In other words, find the dollar amount of the interest. Looking at this problem, you would think there's enough information there, but there's not.
Days.
Well, it's 90 days, so you'd think, oh, there's 90 over 365. But it's not quite that simple. In the banking world, there are actually 2 types of interest when you get down to the day. There's what's called ordinary, and there's exact. If you had your basic accounting class, you've probably heard those terms before. Exact interest is exactly what it sounds like. It's exact. You use 365 days in the year, so it's out of 365 days. This is becoming a more common practice to use exact interest now. Ordinary interest is kind of outdated. Ordinary interest comes from the time when there were no calculators, and a banker actually had to sit down and figure out the interest on their accounts by hand. Can you imagine that, by the way, sitting down? Of course, not very many people had bank accounts, but still sitting down there and figuring out by hand the interest on someone's account and adding it in and keeping track of all the balances in a book where you have to figure it out with paper and pencil, and really suck if somebody spilt their coffee on that book. So ordinary interest is out of 360 days in a year. The reason this was done was because every month was just considered to be 30 days. So every month was just 1/12 of a year, simplified the calculation a lot. 360 is a lot simpler number to work with because 360 can be cross-canceled. It can be divided by a lot of different numbers. So it also simplifies your calculations a lot by using 360. The funny thing is with ordinary interest, some banks still use it because being out of 360 days in a year, if it's a loan, they get to charge more interest. Because guess what? If you keep that loan for a full year, guess how many days they count? 365 days. So you're getting charged interest on 365 out of 360 days of the year. We'll show you that here in just a minute. So let's say that this one is, and by the way, if it is not specified in the problem, you should assume ordinary interest. Exact interest will be specifically called out. So for this one, the amount of interest is the principal of $3,100 times a rate of 6.4% is going to become 0.064 times 90 days over 360. So 3,100 times 0.064 times 90 over 360. $49.60 interest. What do you think? Not so bad? Let's say that Cassie borrows $8,300 at 7.1% simple interest. I'm going to stop writing simple interest in these problems now just because we're going to assume it's simple interest for the rest of the day. 7.1% simple interest for 110 days. Find the amount repaid. Exact or ordinary interest? Ordinary. It doesn't say, so we're going to go with ordinary. So to find the amount repaid, we're finding a maturity value, but we do have to start out with the amount of interest. So we're finding I. What goes in for P? 8,300. R? 0.071 for the 7.1%. T? 110 over 360. Very good. So 8,300 times 0.071 times 110 over 360. $180.06. So of course, we'll take the 8,300 plus $180.06, which will give us $8,480.06. What do you think? To find the maturity value, I took the principal and I added the interest to it. Let's say Tim borrows $4,900 at 5.37% exact interest for 120 days. Find the amount of interest. Tell me what to do. Perfect. Principal is 4,900. The rate is 0.0537. That's the 5.37% is a decimal. Our days, now since it says exact, we're going out of 365, and it's 120 days. So 120 over 365. So now we'll punch it in. 4,900 times 0.0537 times 120 divided by 365. $86.51. Do I have to add that back on for this problem? Why not? They just asked for the amount of interest. They didn't ask for the amount repaid or the maturity value. So you don't have to add it back on. At this point, I'm going to refer you back to page 396 in your textbook, because this next problem, I'm going to not give you the amount of days. You don't have your book with?
The one time I didn't.
Do you need to borrow one?
Wait.
Okay, so on page 396 is that day chart again, so we can look up our days. And what we're looking at here now is, rather than looking at the loan being a 90-day loan or a 120-day loan, in many cases you don't wait till that very last day to pay it off. You pay it off when you get the money. So let's take a look at Pat borrows $5,300 on April 7th at 5.9% exact interest. How much does Pat pay? If paid off on July 19th. So first thing we have to do is we have to figure out the days. We are going from April 7th to July 19th. What day is April 7th? 97. How about July 19th? 200. So we're going to subtract there. 200 minus 97 is 103 days. On the test, when we do these types of problems, a majority of the mistakes are made in calculating the days. Be careful with them. So let's find our interest. 5,300 times 0.059 for the 5.9% times 103 over 360 or 365. It does say exact, so this is 365. So 5,300 times 0.059 times 103 divided by 365. $88.24 in interest. Sure. So then, principal of 5,300 plus the 88.24 means that Pat will pay back $5,388.24. What do you think? Good stuff? Okay. Let's say that Chris borrows $7,450 on November 23rd at 6.4% ordinary interest. Yeah, ordinary, well, simple interest could be either ordinary or exact, but if we just say simple interest, it's implying ordinary. Both ordinary and exact are forms of simple interest. So 6.4% ordinary interest. How much does Chris pay back on February 5th? So again, we're looking at the days, starting at November 23rd, going to February 5th. What's the day for November 23rd? 327? How about February 5th? 36. Now, we got to be careful. Can we just subtract those numbers? No, we cannot. What we have to do is, since we go from one year into the next, we have to figure out the number of days in the first year, which will be 365 minus 327, which is going to give us 38 days. Then you're going to add that to the 36. You got it. Which is going to give us 74 days. What's next? Perfect. So our interest, our amount of interest will be $7,450 principal times our rate, 6.4%, becomes 0.064 times 74 days. And this says ordinary, so it's out of 360. So 745 times. Now I know the numbers I'm punching in may not necessarily match up, but I'm leaving out zeros to shorten up what I punch in the calculator is all I'm doing. So $98.01 sound right? That's the interest. Is that what we're asked for? No, in this case we're asked for what is paid back. So I have to take the principal of $7,450, add the $98.01, see it's $7,548.01. So I'm going to leave you guys with a problem to work on as we go into break. Let's say Tim borrows $3,950 on July 2nd at 11.7% exact interest. How much will Tim pay back? On October 27th. I'm going to leave this problem up on the board. We can take a break. When we come back, I'll give you a little time to work on it. If you want to work on it over break, you can. I'll start talking again probably a little after 6:30. So we'll take our break till 6:30, then I'll give you a couple minutes to work on it after we get back. So it's going to disappear for a second.